Hello, geometry class. This is the notes for section 5.2. What we're talking about here is some properties of perpendicular bisectors. All right, so in the first section, 5.1, we talked about mid-segments. That was the segment that connected a midpoint to another midpoint. Again, inside of a triangle. It had two properties. It was half the length of the third side, the mid-segment was, and the mid-segment was parallel to that third side. So now, we're still talking about triangles, so what we're going to do is draw perpendicular bisectors inside of triangles. So, first thing is a perpendicular bisector. Here's the definition: segment, ray, line, or plane that is perpendicular to a segment at its midpoint. So, if we have segment AB, this point right here we'll call C. That is the midpoint, meaning segment CB is the same thing as segment AC. All right, and it's perpendicular. So we have a 90-degree angle there at the midpoint. So this line, we'll call this line L, that is a perpendicular bisector. It's perpendicular to segment AB and it's going through segment AB's midpoint. So there's some properties for these things. And that's what is in this drawing here. Okay, so I have my segment AB, right? Whoa, I don't want that. What the heck? Cancel. This is a segment AB, and this line right here, this is the perpendicular bisector. Okay, so point D here is the midpoint of segment AB. And what I've done is I just put point C. This point up here, it's just a point on the perpendicular bisector. Okay, it doesn't matter where I move segment AB, how small it is, where I move it around, it has no bearing on anything. Our line is always perpendicular at the midpoint. So, I put this point C on here, and what I want you to pay attention to is those two measurements, segment AC and segment BC. Okay, wherever I move point C on the perpendicular bisector, what do you notice about those lengths? Okay, they're always the same. So that's our property for a perpendicular bisector. It says any point on a perpendicular bisector is equidistant, okay, meaning the same distance, equidistant from the endpoints of the segment. Okay, so if I put a point on here on the perpendicular bisector, this distance will be the same as that distance to the other endpoint. That's the property of perpendicular bisectors. All right, so some examples here. Looking at example number 2. We have this triangle ABC. We have segment BD drawn in. So let's look at some given information. On segment BD, we got a right angle right here. Okay, so it's perpendicular. We've also got these little tick marks here. That means point D is a midpoint. So this segment BD, it's perpendicular at the midpoint. It's a perpendicular bisector. So now, point B is on the perpendicular bisector. That means the distance from B to A is the same as the distance from B to C. And there's our setup. 3x plus 8 equals 7x minus 16. So the key thing here was recognizing this given information that says BD is a perpendicular bisector, so point B is a point on that perpendicular bisector. It's going to be the same distance away from A as it is from C, and now we got our equation. So to solve this, we're going to subtract 3x. We're going to add 16 to both sides. So what we're looking at is a 4x equal to 24. X is 6. The question doesn't really say anything. It just, here's the problem. So we could solve for x. Sometimes the questions might say, what is the length of AB? In which case, you would just take this x value of 6 and plug it in. 3 times 6 plus 8, that is 18 plus 8, 26. would be the length of segment AB. Okay, so pay attention to the question. Is it asking to solve for x? Is it asking what's the side length? You've got to make sure you're paying attention to that. All right, looking at the next example here, number 3. Again, pay attention to some of the given information. We have segment AC right in the middle here, going kind of vertical. We have perpendicular marker right there. We also have these little tick marks here. So, those tick marks are telling us that point E is a midpoint. Segment BD is perpendicular at a midpoint. Whoa, whoa, I just wanted to erase that. And so what we're looking at, this segment BD, it's a perpendicular bisector. So that means any point on segment BD is going to be the same distance away from points A and C. So point B is on the perpendicular bisector. It is the same distance away from C as it is from A. So that means the 6x plus 11 equals 11x minus 9. So we're going to subtract 6x from both sides, giving us 5x. We're going to add 9 to both sides, giving us a 20. X is 4. Okay, and again, same thing. Are you solving for x? Are you solving for a side length? In which case you have to plug the x value back in. So again, the key thing with both of these problems, look at what kind of segment you're dealing with. Look for that perpendicular information. Look for the information that says this is a midpoint. So you're looking for that tick mark and that tick mark. Then you've got a perpendicular bisector. Then you know the property. All right, let's take a look at this one. And actually, I want you to try this on your own. Copy down, hit pause, copy down the information, and we'll talk about this one in class. And just if you want, if you got some time and feel like being challenged, also hit pause and see if you can do this. You're given 3 non-collinear points. You just got these 3 points. Is it possible to draw a circle that will contain all of those? So basically, drawing a circle. Okay, now that's not a good circle. We don't want that one. But you want it to be a perfect circle. Is it possible? Where's the center? How'd you do it? Okay, it can be done. I've given you all the information in this video. You just got to put it together. So give it a shot. See what you can do. But we'll talk about this one in class tomorrow.